Greetings and welcome to another installment of QuantSlob. This is Lucky 13 in our foundational series. This time around, we're going to take a closer look at a couple properties of populations, namely the parameters proportion and average. This is really intended as a piggyback on our previous installment titled Calculating Proportions and Averages. So if you haven't already, you may want to check out that edition, or better yet, check out the foundational series playlist. Let's examine our population of the 52 cards comprising a standard deck of playing cards. Carrying over our wisdom from the last edition, let's calculate the population parameter proportion of cards possessing the suit attribute value clubs. Like in the previous edition, we have our indicator function here called F. There are 13 cards possessing the suit value clubs. So ultimately, our proportion is 13 divided by the total number of elements in our population, 52. This fraction reduces very nicely to 1/4. If we were to solve the proportions of the other three suits as well, this is the distribution we would get. In our soon upcoming series on basic applications, we're going to spend some time talking about different ways to display or convey an attribute's distribution. Here we use a nice little table. Tables are usually a pretty good go-to for distributions. Another popular way to display the distribution of a categorical attribute is to use a so-called bar chart. And here are two essentially equivalent bar charts. The one on the left I made directly inside of Keynote, and the one on the right I made using R. Cosmetically, they're maybe a little bit different, but of course you can see that they tell essentially the same story. The collection of all possible values an attribute takes across the whole population is called an attribute's domain. Here we're using a script D to refer to the collection of all possible values of our attribute suit. This is exhaustive in the sense that if we sum over all the proportions of all the categories, we get a total of 1. Just like we did in the previous installment, I want us to imagine that each element of the population, that is, each card, possesses an attribute that simply indicates whether or not the suit is clubs. If the element, the card, is suited as clubs, this attribute will possess a value of 1. If the card is not suited as clubs, this attribute will take a value of 0. This attribute here offers a value as a quantity, namely 0 or 1. So it is a quantitative, or if we prefer, a numerical attribute. Now we're going to take the average of this numerical attribute over the population. Interestingly, we get the exact same value, 1/4, as we did when we calculated the proportion of the suit attribute's club label. The average of a 0-1 indicator, like we just fashioned here, is the same as the proportion of the original factors category. It's quite a convenience, actually. Okay, moving on. If we were to solve the proportions for the printed rank label of our cards, this here would be the distribution in table form. With our population, each rank is represented 4 times. 4 divided by 52 reduces to 1/13 like we have here. Let's call our card rank attribute R. The domain of values of our card's rank label includes 13 elements, 2 through 10, Jack, Queen, King, Ace. There's a gym game or workout program that involves a deck of cards. There's a few different flavors of the game, I think, but in one, you and your workout partner take a deck of cards, and whatever exercise you're doing, say you're doing squats, you would flip a card, and if it was a jack, say, you would have to do 11 reps. Then your partner would flip the next card, and if he or she got, say, an ace, then they would do 14 reps, and you would each take turns until you had flipped all the cards. So that would be a total of 26 sets each. What then would be the population average of this quantitative attribute based on the printed rank label? We sum up all these quantities, they sum to 416, and divide by the total number of elements, 52, and we get a value of 8. So we can say that if 2 people played this gym game, that when they were done, the average number of reps the 2 participants did, or should have done, per set is 8. Lastly, the attribute integer rank value that we created is variable across elements. Same with the attribute card suit. The parameters we calculated, like the average of our integer rank values or the proportion of cards that are suited as clubs, are invariant or constant across our population. And we can and should think of these values as themselves properties or attributes of the population itself. And that's it. That's going to do it this time around. Thank you very much for tuning in. Greatly appreciated. And don't forget to stay tuned for more Quant Slob.